So good evening, everyone, and welcome at our first of two online chemistry career nights. This event consists of 2 evenings, and today the first part will deal with the opportunities within academia. 3 speakers will share their knowledge and experience with you about their career within academia. And afterwards, they will be glad to answer all your questions you still may have. This career night is a collaboration between the KVCV and the KNCV. So we will first shortly introduce both societies. And I will start with introducing you to the KVCV. So the KVCV is a Royal Flemish Chemical Society. And we are a community of chemists in Flanders and far beyond, because everyone can become a member of our society. Our members mainly are students, PhD students, academics, teachers, and professionals. So we really do represent and strive to support everyone within the chemical education industry and society. We mainly organize lectures about popular scientific topics for the general audience or more domain-specific workshops. And afterwards, we typically have a networking reception, but unfortunately in the digital editions, that's not possible. Here you have an overview of our upcoming events. If you want any more information or if you want to register for an event, I would recommend you to visit our kvcv.be/calendar webpage. EUCHEMS, the European Chemical Society. If you are a member of KVCV or KNCV, then you're automatically also a member of EUCHEMS, so the European Chemical Society. And as a member of EUCHEMS, you have discount at various activities organized or endorsed by EUCHEMS. Our webinars are supported by Chemistry Europe, so have a look at their journals as they might be of interest for your next publication. So let's stay in touch. If you need any more information, you can always visit our website, kvcv.be, or we can also be reached via our social media channels. We have a Facebook page, but we also have a YouTube channel on which all our webinars can be rewatched afterwards. And we also have a LinkedIn page. And then now I will give the word to Hanneke Reinders, who will shortly introduce to you the KNCV.
Yes, thank you, Nathan. I will share my screen with you to tell a bit about the KNCV, which is the Royal Dutch Chemical Society. We are actually quite similar to the KVCV. We do largely the same stuff, but then in the Netherlands, we want to make chemistry and chemists more visible within the Netherlands. We connect chemists in the Netherlands. Because we think that, yeah, chemistry and chemists make our world every day a little bit better. And how do we do that? Of course, we do that with events like this career event. We also have about 17 subject-specific sections. You can also become a member of those. These are sections for example, on analytical chemistry or organic chemistry, biochemistry. So you can become a member of those sections and they organize events in that subject-specific area as well. And if you are a member of the KNCV, you can have one meeting with a career coach for free. We have a couple of career coaches we are connected to, and you can also talk to them if you want to explore more about your career opportunities. We also have a platform called Eye Openers. Below in the screen, you can see a few examples of those. These are videos of about 1 minute where researchers explain what they are doing. So that's a nice way to explore chemistry research in the Netherlands as well. And we have C2V International, which are articles translated to English that you can read online, because we of course have the C2V magazine, which is in Dutch, but if you don't speak Dutch, you can also read some of the articles in C2V International. We also have Jong KNCV, if you are a member and you are below 35 years. which most or maybe all of you are automatically a member of Young KNCV. They organize events as well, like you can see on the picture, an online pub quiz last year. They also have a webinar about beer this Friday. Unfortunately, you cannot subscribe anymore because you, as an attendee, you will receive some beers at home. And you can follow Young KNCV on Instagram as well. They are active there, so you can stay up to date via Instagram. There are some KNCV activities coming up as well, which I would like to tell you about. About every month we have a webinar. Those are in Dutch. The next one is on the 26th of May about hydrogen. And also on 12th May, there's another career event organized by Young KNCV. This event is for people that are already working. So it's not aimed for students or PhD students, but specifically for people that have a real job, so to say. You can subscribe for that as well. And in October, we have the Avond van de Chemie, which is our nice big event. Hopefully it can take place physically, otherwise it will be digitally. And you can also follow us on social media if you not already do so. You can follow us on LinkedIn, Twitter, Facebook, and Instagram, which is only for Young KNCV. And that was it about KNCV, what I wanted to say.
Okay, thank you very much, Hanneke. So we are now about to start our evening and the first presentation. If you have any questions during the presentations, you can always ask them in the Q&A section of the Zoom platform. So please don't put them in the chat, but in the separate Q&A section. That's much easier for us. And then we can afterwards ask them to the speaker. And let me now introduce you our first speaker of this evening, Leana Travaglini. Leana obtained her PhD in chemical sciences in 2014 at the Sapienza University of Rome. She worked on the synthesis and self-assembly study of amphiphilic molecules under the supervision of Andrea D'Annibale and Luciano Garontini. Afterwards, she joined the group of Luisa De Cola at the University of Strasbourg, where her research focused on developing new mesoporous organosilica materials. Since 2018, Leana works at Wiley as an associate editor. During her talk, she will give an overview of the publishing process and the different steps a paper has to undergo before it is accepted. She will also deal with questions that are frequently asked professional editors. So I will give now the word to Leana, and I would say the screen is yours.
Hi, everybody. Thank you for your kind introduction. And also thank you for inviting me tonight. Tonight, I'm going to talk about the publishing process at the Chemistry Europe journals. And in particular, I will do so by discussing the role of the scientific editor, which is also one of the possible career paths after a PhD in chemistry. But before starting, I would like to tell you something about something more about me. Nathan has already told you something. So I come from Italy. I studied Italy at the University of Rome. I studied chemistry, and I also obtained there my PhD in chemical sciences. I worked in the groups of Luciano Galantini and Andrea D'Annibale, and during that time I synthesized surfactants, and I studied their properties and their self-assembly, mainly in water. During my PhD, I also had the opportunity to spend time abroad as a visiting PhD student, in particular at the University of Costa Rica and at the University of Bristol in UK. And afterwards, I moved to France, to Strasbourg, where I worked as a postdoc in the group of Luisa De Cola on new mesoporous silica materials. And in September 2018, I joined Wiley-VCH as an assistant editor, which is the entry-level position. And I started to work immediately for Chemistry, a European journal. And then I stayed on, and I'm still working for the journal as an associate editor right now. During this presentation, I'm going to first give you some context by telling you something about Wiley-VCH and Chemistry Europe. And then I'm going to introduce you the editorial team, the people behind the journals, and discuss more in detail the editorial process and what actually the editors do. And then I thought I would finish my presentation by giving you some tips for the preparation of manuscripts that I think might be useful for authors at the early stage of their career. So as I think many of you are. As you probably already know, Wiley is very well known for some of its products. It's a global company and it has offices all around the world. The office I work in, it's located in southwest Germany in a small town called Weinheim, and it's known as Wiley-VCH. The name comes from the fact that in 1996, Wiley acquired VCH, Verlag Chemie, the publisher of Angewandte Chemie. And as you can see, this year marks also a double anniversary for the company. Two are the factors that characterize Wiley-VCH. The first is that it has in-house editorial offices. This means that the editors are devoted full-time to the journals and do not work also as active researchers in academia. The second is that it's a publisher for the chemical societies. For example, for Chemistry Europe. Chemistry Europe is a collaboration, it's an association of 16 European chemical societies. It was founded in the 90s and it was known until last year as ChemPubSoc Europe. It co-owns it co-owns 19 journals that are published with Wiley. And I work at the moment for 3 of these journals. The first one is Chemistry European Journal, as I mentioned earlier, which is the oldest journal of Chemistry Europe, and it's the flagship journal. And it publishes on, it's a general chemistry journal, so it publishes on all areas of chemistry. And last year we celebrated its 25th anniversary, and we did it with a change of look, as you can see. And we also celebrated its 1000th issue. Very recently, I also started to work for Chem Systems Chem, which is a smaller journal, and it's specialized, and it's one of the youngest of our sister journals. It publishes on all aspects of systems chemistry, from out of equilibrium self-assembly to microfluidics, artificial cells. And the other journal I work with, is Photochem, also specialized, a smaller journal, which publishes on pure and applied electrochemistry. But let's go now and see who are the people working for the journals and what they actually do. So here on the left, you can see 2 pictures taken clearly before the pandemic of the editorial team of Chemistry European Journal. You can see the team is quite big, as Chemistry European Journal is the biggest of our journals. And on the right, you can see my colleagues from Chem Photochem and Chem Systems Chem. Unfortunately, we still don't have a picture together as we haven't returned to the office yet. The editorial team is composed mainly of editors, scientific editors. We all have a PhD in chemistry. Most of us have also an experience as postdoc. And the team, in particular for Chemistry European Journal, is multidisciplinary. Editors take care mainly of the peer review process and of some of the production tasks, but are also involved in other activities, and I will talk about them later on. As you can see from this diagram, the editorial process from the moment a manuscript is submitted to its final publication can be quite complicated, and our job is basically to handle the manuscripts throughout the entire process. The core of this process is the peer review, which is the evaluation of a work by 2 or more experts in the field, as for sure everybody knows, all of us know. It's a very important process because not only it helps determining if a manuscript is suitable for publication in a specific journal, so it helps assessing if the science is sound, if the work is significant, if it's effectively communicated, but it's also a great chance for the authors to improve their work in terms of both presentation and work itself, based on the feedback that they can have from this process, both from the reviewers and the editors. Our role in the peer review process is initially to assess the manuscripts as soon as they are received by the editorial office. So we decide whether we send them to peer review or not. We select the reviewers. We then have to assess the quality of the reviewers' reports, and based on them, we make a decision on the manuscript, which can be acceptance, revision, or rejection. And we also deal with appeals and ethical cases where, when it's necessary, when it's the case. Our job is, our responsibility is to handle manuscripts in a fair, timely, and confidential manner. As for the initial step of the peer review process, what happens usually is that when manuscripts are received by the journal, the editor-in-chief assigns them to the associate editors based on their scientific background and their experience. And we evaluate the manuscripts and in their entirety, but we at first we pay special attention to some parts of the manuscripts, which are specifically the cover letter, which is not technically not part of the manuscript, but it's a very important part of the submission. Then title, abstract, introduction, figures, conclusions, and references. Not always, unfortunately, we send manuscripts to reviewers, and this can happen for several reasons. Manuscripts can be too specialized for a general chemistry journal, for example, or can be out of scope. We also don't send it to reviewers when when results are too incremental compared to previous work, or if previous work is not properly cited, and then the work present in the manuscript is not put in the right context. And also in case of unethical behaviors. The latter can be many and different. Unethical behavior is, for example, the fragmentation of a work in order to get out of it the highest maximum number of manuscripts. Then duplicate submission, which can result also in a duplicate publication of data. And then, of course, plagiarism, and also self-plagiarism, and fraud and data manipulation. Sometimes, as for data manipulation, it's quite easy to spot it, as you can see from these couple of examples that are reported here that we observed over time. So sometimes we see peaks that are very badly removed from spectra, or baselines that are just made up by repeating a peak sequence. As for plagiarism, instead, we have a tool that helps us detect it. We scan, all manuscripts are automatically scanned through a similarity check software that highlights all sections of text that overlap with previous publications. And this helps us this gives us an idea of the extent of overlap of a work. But what happens when we send the manuscript to reviewers. We have to choose them. And this is something that we are often asked about. How do we choose reviewers? We have different ways. We look at the references or similar papers published on the topic. We have an internal database with thousands of referees. Also, we make the choice based on our experience. We know who is reliable and expert in a specific field. We, of course, sometimes ask members of the editorial board and consider also the suggestions of the authors. But in this case, proposed reviewers shouldn't be collaborators, former co-workers, or supervisors, and we do check that. Once manuscripts are evaluated and we receive the reviewers' reports, we need to assess these reports. We cannot just forward them automatically to the authors. We need to make sure that we have a sufficient number of reports, that they are consistent, and if not, we need to contact, for example, additional reviewers, and we need to check the quality of these reports. A good report is constructive, it doesn't contain personal criticism, and any judgment in it is supported and explained by, it's supported by an explanation. For example, comments like these ones that we received and receive often are not really useful, are not constructive, and they do not help the scientific discussion. Once we have good reports and a sufficient number of reports, we can make a decision on the paper. This decision can be, in the best case scenario, the acceptance of the paper as is. Often we ask the author to revise, to make changes to the manuscript based on the comments of the reviewers. And unfortunately, sometimes we have to reject papers. However, in most of the cases, when it's possible, we try to offer a transfer to one of our sister journals. This helps, in fact, having a faster peer review process at the other journals. Sometimes, for example, after revision, a manuscript can be directly accepted without a further round of peer review. And about 70% of rejected manuscripts are offered a transfer to one of our sister journals. And with 70%, I mean both those rejected after the initial evaluation and after peer review. But let's talk about something more positive, and let's see what happens when a manuscript is instead accepted and what leads to its publication. So when a manuscript is accepted, we are at the end of the yellow band here. And as you can see, there is still a lot of work to do. What happens is that the very same day the article is accepted, it can be published, it's published online as accepted article if the author wants. Then in the meantime, the manuscript is checked by our editorial office. It's copy edited. We make sure that all parts of the manuscripts are there, that figures are of good quality. We check the abstract title, references, like how the manuscript looks like, and we send the manuscript to the typesetters. And they prepare a PDF version of this copy-edited manuscript, the so-called galley proofs, that are then sent back to the authors for final approval. And at this point, the authors can still make changes, small changes, not scientific changes. And once we make those changes, the article is ready to be published online in its final version, the so-called early view. And it's finally included in an issue and given a volume number and page numbers. And as editors, we take care of the copy editing process and of the issue compilation at the moment. We are also involved in other activities for the journal and for Chemistry Europe, as I mentioned earlier. For example, the Chemistry European Journal last year launched a new series of articles, Science Voices. Here I just reported a couple of examples, and these are articles in which authors can express their opinion and their views about several topics. We plan and organize and oversee the production of special issues. Special issues are issues dedicated to specific, that can be dedicated to specific topics or related to conferences, or they can celebrate special occasions. And these are a few examples from last year. And similar to special issues, we also plan and organize special collections. We do that also often in collaboration with other journals. The difference is that while the articles are published are included in regular issues as soon as they are accepted, and then they are collated on a virtual issue online on our website. And they can also be dedicated to topics or conferences, or they can celebrate something in particular. Some of us also select the cover features of our issues, and sometimes, especially in case we organize a special issue, we can also create them, which is kind of cool. And finally, part of our job, but not less important, is to stay in contact with the chemical community. So we usually participate to conferences, special events, we give seminars, or we visit research institutes. Of course, last year, none of this has been possible. So to stay in touch with the community, we organized and we keep organizing virtual symposia. They are listed on the Chemistry Europe website. And as you can see, also in the next 10 days, there are a few planned. And you can also find recordings from previous events. And finally, we also manage our social media accounts, where we where we post about published content, or we promote events, or communicate news to our readers, authors, and viewers. And I would now going to the last part of my presentation and give you some tips for the preparation of a manuscript. What's really important when you're preparing a manuscript is to know your target readership, to think about what journal you would like to publish your paper in. Because if you plan to, if you plan to publish on a very specialized journal, or on a, for example, a general chemistry journal, the manuscript would need to be written most probably in a different way, and the topic presented differently. And it's also important to check the author guidelines that are usually on the journal websites, and to check if there are special requirements or things to be aware of during the preparation of your work. And earlier I mentioned a few parts of the manuscripts that as editors we first look at, and I said that the cover letter is a very important part of the submission. It's in fact the occasion the author has to talk, let's say, directly to the editor and tell them why their work should be published in their journal. So the cover letter should normally be addressed to the editor-in-chief, should contain the key results, and should state clearly what is the novelty and significance of the work. You can also, in the cover letter, propose reviewers, but you can also mention reviewers that could have conflict of interest and that should be, for example, avoided. As for the title, which is also an extremely important part of the manuscript, it should be specific. You can be creative, of course, but without exaggerating, let's say, and it should contain keywords. Going more into details and giving you some examples, let's see this title, Effect of Metal Catalyst on the Outcome of Coupling Reactions with Aryl Alcohols. This is not a good title because it's not precise, it's not specific. It does leave open so many questions, while for the same work, this title would be better because it's specific, it's concise, and it contains keywords. And there are many, for example, ruthenium trichloride, aryl alcohols, alkylation. The abstract is also a part of a paper which is more often first read by readers and editors. So it should convey a message. It should be simple, complete, and informative. We usually say that it's good to keep in mind the so-called 20 seconds rule. You should think you have only 20 seconds to explain your work to a scientist who is not familiar with it. So you should try to convey the key ideas and the main findings by using keywords, only the most important and significant data, and there shouldn't be any information that needs context to be understood in the abstract. By talking about title and abstract, I mentioned a few times the keywords. They are important as they help your paper to be found. So you want your manuscript, your work to be found, read, and eventually also cited. So it's good to keep in mind when preparing your manuscript that search engines, for example, Google, normally display only about the 60 characters of a title and first 2, maximum 3 sentences of an abstract. So it's important that keywords are placed in this section. So beginning of the title and beginning of the abstract. It's also a good idea to repeat the keywords in the abstract a few times, to keep your title short. Very long titles do not help. And to avoid, for example, in the title, the use of empty phrases like study of or recent advances in reviews, in review articles. Also words that are overused like novel, and it's also good to avoid any uncommon abbreviation. Let's go now to the introduction. Introduction, it's also an important part because it's, as the word says, introduce your work. So it should say why you did that research and why the advances you are presenting were necessary for the community. And it's important to put your work into the right context by outlining the state of the art and therefore citing the most relevant literature. Something that also catches the attention are graphics. Graphics should be always clear and easily legible. It's always a good idea to avoid very crowded figures with a lot of plots and figures that can be confusing to the reader. They should also always be provided in high resolution, and it's always a good idea to check in the author guidelines if there are special requirements from the journal. And finally, let's go to the last part of the manuscript, which is the reference section. A good reference section is usually a good balance between the original first works on the topic and the most recent findings. It should be it should give a complete overview of the field. Over-referencing should be avoided. This means that you should avoid providing too many similar references on the same topic, also references that are not really pertinent to the topic, but they only cite it, for example, as a, and they are not focusing on that. You should also not reference too much your own work at the expenses of relevant work also from other groups. And it's important, of course, not to miss any important article which is related to your manuscript, and it's therefore always a good idea before submission to recheck the references and the most recent literature. Sometimes the preparation of a manuscript can take time, so things can come up during preparation, so it's always better to check. And with this, I conclude my the tips I would like to give you tonight. But they were only a few. So if you are interested in having more information about how to find the right journal or how to prepare your manuscript, the open access licenses, and other information about the publication process, you can check this guide, how to get your paper published, which is available on our Chemistry Europe website. It's for free and you can download it as a PDF. And I hope it will help you. And with this, I would like to conclude and thank you for your kind attention. If you have any questions, you can also email me afterwards at the email here on the slide.
Okay, thank you very much, Leana, for your nice presentation. So for the participants, if anyone has a question, just ask in the Q&A section. But since there are not yet questions posted, I will do one myself. So during workshops about writing, I hear a lot that you don't need to use too much difficult jargon words in, for example, the title or the abstract. But you just said, be specific. So can you maybe extend a bit on that?
Yes. Let's say that it depends, of course, also on the journal you're submitting your manuscripts to. That's why at the beginning I said it's really important to target your audience. For example, in a general chemistry journal, it's important that everybody from all fields can understand your work, what your article is about. Of course, extremely specific words should be avoided, but there should be a compromise, like a title that doesn't give you any idea what the work is about. It's not a good title. So as for the examples I showed you before, we can be very generic, but that article wouldn't would not attract any interest from probably neither specialists in the field or nor just other readers that could be attracted to it. So yeah, specific, maybe not too much, but certainly not too generic.
Okay, yeah.
There should be avoided like words that are too difficult, maybe, because also we should keep in mind that we are not all native speakers. So language should be easily understood by everybody. So
compromises should indeed be made on that.
Yeah.
Yeah. Meantime, we have a question in the chat. So how was your experience starting at Wiley, switching from writing articles to evaluating articles?
Okay. It was extremely exciting. At the beginning, of course, it's a big change. But we are trained during the entire first year by seniors editors and our deputy editors. So we are not just left, with the articles to evaluate, and we learn how to go through them, what are the aspects that are important for the journal, what is the quality the journal aims to. So it was a long process at the beginning, but it was extremely interesting also to be on the other side and start looking at manuscripts from another perspective.
Okay, I think that was very clear. Then another question, someone who thanks you for the nice presentation and asks what qualification did you need to become an associate editor, and what do you think helped you the most in becoming an editor?
Okay, you need to have a PhD in chemistry. For example, a postdoc is not necessary, although many of us have it. I think what helped me the most is also having had experiences abroad in international groups, and having the possibilities also to interact with many scientists. I think in my case that probably helped, but as a requirement, there is the PhD in chemistry, so there is no other specific requirements. Knowledge of the field you have studied and you have done your PhD, and interest for the
interest of
yes,
like with everything I think in life. So.
Yeah, exactly.
Then there's also a question. I noticed you did not mention the supplementary information. Are the editors reviewers looking into this with much detail, and what is a good rule of thumb on what to include in there?
Yes, so we do look at the supporting information. I didn't mention it just as of a matter of time. Normally we, for Chemistry European Journal and many of the Chemistry Europe journals, our articles can have at the end of the main text a short experimental section. Usually we suggest the authors to reserve that section to the most important findings, like if there is, for example, a new procedure or a new compound. We would suggest not to report, for example, methodology, general methodology description, for example, solvents used for the NMR or the NMR instrument, for example, in that section, but to move that to the supporting information. So the supporting information can contain any supplementary data. There is no restriction about that. You can also upload videos, for example. It usually should be organized based on the several techniques or data you're reporting. And we also suggest to report data that are sometimes one prepares a manuscript, tends to report mainly the data that support the statements that is making in the manuscripts, but sometimes there are also side experiments that, for example, didn't work, or that are only quickly mentioned in the text. We also suggest the authors to put those data in the supporting information, because they can still be useful to a reader or to somebody that is trying to replicate the experiments.
Okay, so it's not really the part of the review process, but it is, of course, important.
It is. We do check the supporting information and also the reviewers, and we also sometimes ask the reviewers to look at specific parts. For example, if there are X-ray structures, usually these are reported as supplementary files, with the check reports. And they are checked. Every part of the manuscript, not only the main test, is subjected to peer review, but also supporting information. We also check, for example, that the data reported for compounds or materials are sufficient, because, for example, if you report a new compounds, you will have to characterize it properly. So specific data are required, for example, and proton and carbon NMR spectra, high resolution mass, elemental analysis for organic compounds, and so on. So yeah, we do check that, and it's completely subjected to peer review.
Okay, then there's another question, I think also very important for a lot of people. How do you make the best choice between dividing your results over multiple articles or going for one longer article then? And what do the editors prefer?
So there is not really something we prefer. What should be avoided is, for example, taking a work that could be complete and could make a nice manuscript and dividing it on purpose just to make more articles about it. For example, I prepare a new material and I studied, I don't know, its physicochemical properties, and then some other specific property more that this material has, and then I divide this study into manuscripts. This maybe could be avoided, but for example, if during my PhD I work on specific reactions and on a specific new method, and I focus on that during my entire PhD, doesn't mean that we have to publish only one manuscript about that. So as long as the results make a good, complete piece of work, that is fine. You can see when you see that something is missing, and then you maybe check in the literature and something else on that material or that compound has been already reported, and you maybe only like the month before, and you can see that this has been divided on on purpose just to make more manuscripts out of it.
Yeah. Okay.
It's really like a general rule that applies to all manuscripts. It really also depends on the work.
As long as the quality, the quality of the work is still okay, then okay.
Yes, exactly.
I think, yeah, you covered a lot, very clear, very useful, and there are not no questions anymore. So I'm very thankful. Thank you so much for your nice presentation.
Thank you all.
And then we can go to the next, the second part of this evening. So in the second part of this career night, Richard Hoogenboom and Timothy Noel will talk about their academic career so far and discuss their path to their current position. They are in particular in a perfect position to tell you more about the differences and similarities between the Belgium and the Netherlands concerning the academia. Sorry. So first, let me introduce you to Richard Hoogenboom. Richard obtained his PhD at the Eindhoven University of Technology under the supervision of Professor Ulrich Schubert. Afterwards, he joined the group of Professor Martin Muller in Aachen and Professor Roland Nolte in Nijmegen as a postdoctoral researcher. Richard is currently editor-in-chief for the European Polymer Journal and associate editor for the Australian Journal of Chemistry. Since 2010, Richard is heading the supramolecular chemistry group at Ghent University, and from 2018 onwards, he is also co-founder of Avroxa BVBA, which commercialize polyoxazolines as Ultroxa. So I'll now give the word to Richard.
Okay, thank you, Nathan, for the kind introduction. So let me share my screen. Okay, so you should all be able to see my screen now. So this tonight is going to be quite a different lecture for me to give. So usually I focus on scientific lectures. Today I prepared a couple of slides to mostly show you the career path and the lessons I learned at the start of my career. So before I became an academic and before I started my position and my own research group in Ghent. So I gave it the title, How a Dutch Chemical Engineer ended up in the Faculty of Sciences in Ghent. So I have a training as a chemical engineer, but during my master, I already specialized towards organic and polymer chemistry. And then with my move to Ghent, I ended up in the Faculty of Sciences. So my path was already briefly discussed, but what I show here is, well, the guys that actually made it possible for me to have my academic career. And I will use this timeline. So this is the broad timeline of how I started my career. So mostly up to 2010. This is when I started in Ghent. So I will mostly be talking about this part and give you tips and advice on how I addressed challenges of being a PhD student with the intention later on to become an academic. I showed these guys here because they are very important for my career. And I will start with this quote here, and I will repeat this several times tonight. Network is everything. So if you have the ambition or the dream to become an academic researcher, to have an own independent research group, it's important that already today you realize this and you start building your network. So nothing comes automatically in life. If there's opportunities somewhere at the university, either in the Netherlands or in Belgium, you would like the person in charge of hiring a new academic. You want that this person somehow thinks about you as a potential candidate. And if you can reach that stage, this is a very good stepping stone to get into academia. So network is really important to already today start considering. I think the fact that you all subscribe to this evening is already a good indication that you're aware of this, even though we will not be able to have any drinks tonight to informally discuss things and informally further build the network. Now, a few words about science. So the research in my group focuses on smart and responsive materials, and this comes from the inspiration from looking at natural systems. So in my view, proteins are the smart and functional nanoparticles of living matter. They are able to respond to all kinds of changes in the environment. Like if we focus the eyes, we change the muscle, we change the curvature of the lens, and this is all a molecular mechanism from the muscle, from the protein. As somebody focusing on polymer science, I would like to see these proteins as synthetic, perfectly defined polymer chains. And nature is able to make these polymers to read out RNA to build new proteins so they can self-replicate. Proteins can be used to make actin filaments, which give strength and viscosity to cells, but also proteins can have very sophisticated function like this motor protein here that can walk over an actin filament to have this vesicle cargo moved from one side of the cell to the other side. But as a polymer chemist, nature is actually quite limited because they just have 20 amino acids to build all these different functional protein structures. So I believe that as polymer chemists, by selecting the right building blocks, we can make thousands and thousands of different monomers. We should be able in the end to do better, get inspiration from nature, and make even better smart material than nature has done. Now, this is, of course, a quite bold statement, and I do realize that, of course, my time is limited. Nature had several billion years to do this. I will probably just have 30, 40 years left to do this. Well, why do I show you this introduction slide tonight? Because if you want to be known for your research, it's important that you tell the right story to the people, and you have to position your research. So you have to make people aware of why you are doing your research. That's the most important. First, convince them why it's important what you do. After that, you should tell them how you're going to do that, so that you'll see on the next slide. And then on the third slide, the third instance, you can then go to specifics and explain people what you will be doing. Similar in writing an introduction of a manuscript. To follow up the previous lecture, start in the introduction with the why it's important what you do, how will you address this specific question, and then tell what you have done to actually address this question. So based on this inspiration and philosophy, In Ghent, I've started my research group in 2010. And what we are doing is we use molecular engineering to build functional materials. So we really try to understand a certain need for a material. Then we go back to the drawing board. We make new molecules that can be new monomers, can be new initiators. And then we make a defined polymer which has a certain functional property. And to do that, we make responsive polymer structures. For example, here, this is a micelle system that can capture calcium. And then if you heat it up, it releases calcium. So this is a system for very low temperature regeneration for softening of water. You can take out the calcium, you make it softer. You can easily regenerate with a mild temperature trigger. We look at supramolecular polymer materials where we combine defined polymer building blocks together with specifically supramolecular interacting units, for example, here terpyridine. And this is then combined in a tough hydrogel that is able to do energy dissipation. And the third main research line in my group are polyoxazolines. So you see here this structure, synthetic polyamide that resembles proteins and that we can use to eventually replace polyethylene glycol and to make the next generation of biomaterials. Again, why do I show this to you? This is, I'm very well aware of a show-off slide. So these are the best publications of the group from the last 10 years. But if you want to be recognized, I think you should not be too afraid to emphasize your achievements. So if you want people to remember you, you also have to give them something to remember. And besides that, you should explicitly mention the unique approach you're taking. So the unique approach we take is this molecular engineering towards functional materials. So it's very important to already now, today, start positioning your research and start selling it to the outside world so people will remember you. This is just a slide because I want to acknowledge my group. So you see here the group picture. It was a group trip we did 2 years ago was the last time we were able to travel with the entire group. For me, it's extremely important to have a good atmosphere and a good friendship between the researchers in the group. It's 20 people. They don't have to all be friends, but they need to be going well together, and there should be small groups of friends so they are really willing to work together to achieve the research. Okay, so I have this research group running. So of course, I would like to address today, how did I get there? And what I would like to already mention here, I never planned to become a chemistry professor. So I sometimes admire some people really dreamt from very early on that they want to become a chemistry professor, they want to change the world. I never had that. So I did my secondary school. I really liked all the beta subjects. And then I was doubting if I would study chemistry or no, not initially. I considered mathematics and physics. And then in the end, I ended up with chemical engineering because it was a nice combination of doing a lot of mathematics, physics, and then going towards the chemistry. So it was kind of, arbitrary choice that I ended up in chemical engineering. And then during my studies, I realized chemical engineering was nice, but chemistry was even nicer. So the conventional career path towards academia, well, I put here, does it exist? I think you can question whether there is a conventional career path and whether you can do any career planning. But most people would follow a track like this. They do a Master of Science, they do a PhD, they go a postdoc. In my case, that should have maybe have been US or Australia, and then go back to the country where they grew up, and they become their associate or assistant professor to start. So this would actually be assistant professor, realistically. So that's the most common path. And then you saw previously my timeline, rather unconventional. I did a Master of Science, PhD. Then I became project leader in the same research group where I did my PhD. Complete no-go. You should normally not do that if you talk to people. Then I combined the last years with a part-time appointment at a spin-off company at the university. Then finally I did my, well, in between brackets, foreign postdoc. I went to Aachen, 10 kilometers across the border, but still considered a foreign postdoc. Then back to the Netherlands for a postdoc, and then suddenly ended up in Ghent. And I will share with you how this all happened. But the take-home message from this slide is that every career is different, and there's no good way to do it, there's no bad way to do it, but you just should be aware of some important factors that you should work on if you're aiming and dreaming of an academic career. So in my Master of Science in Chemical Engineering, I did this in Eindhoven at the Technical University of the Eindhoven University of Technology. During this master, I went for 3 months to the University of Cambridge in the UK. It was a very good personal experience. Not sure if it really helped so much later on in my career, but it was really important for myself to become more independent. And then I did my master thesis with this guy here, Bert Meijer. And only during my master's thesis, I started to realize how much this professor actually has already achieved and how famous he is. So I actually studied chemistry. I wasn't aware of so much of science, of what was going on. And then I ended up with this guy because I really liked organic chemistry. And then later I found out that he's amongst the top 100 most cited chemists. So this was actually a lucky shot in my case that I choose to work with him. It has helped my career for sure, maybe not directly, but indirectly. But I'm telling you this so that if you're not doing your master's thesis yet, it's something to keep in mind that if you already start building your network by picking the right supervisor, this can help later on. So then after my master, I liked research in my master thesis, so I decided to stay a bit longer in science and to do a PhD in Eindhoven. And I choose to work with this guy, Professor Ulrich Schubert. At the time, I think he had a bit more hair still. This is a more recent picture. And I joined Professor Schubert when he just started in Eindhoven and he started his independent group. I was the 5th student joining the group. And that was again my luck that I joined very early on, because when I finished my PhD, we had about 25 people. So that means I saw the group growing from 5 to 25. I saw all the new projects starting from scratch. And some important factors during my PhD, and this is in retrospect. At the moment when I was doing this, I wasn't so aware. But I joined this very ambitious young professor that was eager to publish. And if you want to go for an academic career, if you want it and if you like it or not, publication list is not everything, but it is part of it. And if you have no publications after a PhD, this is not a good sign to move on later. So make sure you choose a PhD supervisor that likes to publish and not one that didn't publish any paper in the last 5 years. Well, then the fact that I started a young group, that means that I learned many different projects. And very importantly, the group I choose was very collaborative, meaning that we had group meetings with the entire group and there was no secrets. Everybody shared everything with each other, meaning that you could also very easily collaborate and start new projects with your colleagues. Now, some other important factors here for the PhD. So try to attend and present your work at conferences. So I did 2 to 3 international conferences. I was allowed to do that. So I was very thankful during my PhD. But then if you go to a conference, then don't just present your work, but really try to push yourself to ask questions to the other speakers. So if there's a famous professor, just be brave, raise your hand, ask a question, or after the lecture, go there, introduce yourself and ask a question personally. Well, in our group, we had regular visits and lectures of top scientists around the world. So the one I remember most is that we had a visit of Jean-Marie Lane, so the Nobel Prize winner. He came to visit our research group and we had one-to-one discussion. So I had a discussion with Jean-Marie Lane in my office. And that's, of course, a perfect way to build your network. And then for the last point, I think this is something you have a bit more in your own hands. Once you reach the end of your PhD, you should really try to convince your supervisors to have some famous 1 or 2 professors in your PhD jury, because these are people that will read in depth your work. And if they are impressed, this can really help further on. So this is all to start building your network during the PhD already. Well, I had a very flexible research topic. So that means that I did a lot of things. So in the Netherlands, we like to do this so-called Friday afternoon experiment. So you have a crazy idea, and then just a Friday afternoon you spend to try the crazy idea, try a reaction that your colleagues tell you you're crazy because it will never work. If you try enough of those, you will eventually find one that actually does work. So try to work hard, try to do a lot of things, try to do a lot of things in parallel, because the more you try in research, the more chance of success that you will have. We all know that science is mostly failure, and then every now and then something works really beautifully. Well, the more things you try, the more things will work beautifully. And then supervise students, try to collaborate with your colleagues, because the output, as I mentioned before, will be important for the further academic career. It's not everything, it's not just a number, but also the impact of the journals and of the work that is very important. So I told you, make sure you have a nice PhD jury that is examining your thesis. So I just dug up this old picture. So this is 2005. So I'm here in the middle, just a fresh young doctor. You see my promoter. This is a gentleman. It's George Newcomb, a very famous professor that was one of the very few first people working on dendrimers. So I regularly see him in the US at ACS conferences. Alex van Herk, he was in Eindhoven at the time, now is a professor in Singapore. Some of you may recognize this gentleman here. It's Professor Philippe Dupré, now a colleague in Ghent. And this is Yusuf Yaji, a very important polymer chemist and famous polymer chemist from Istanbul Technical University. And this guy is from Avantium Technologies, Gert-Jan Gruter, the CEO. This is the CEO of ChemSpeed Technologies. And this is Yoshiki Tsuyo, so also a famous professor from Kyoto. So you see that, well, I really tried to convince my supervisor to get a good international jury for my PhD. And you will see later on why I put this picture, because you will see one of those guys back, the name. So at the end of my PhD, I kind of started to consider that maybe I wanted to do an academic career. I wasn't sure yet. I still liked science, but I didn't really make up my mind if I wanted to go or stay academic or not. So I actually stayed and decided to stay in the same research group. So I became a project leader for the Dutch Polymer Institute, the DPI, but my working place was exactly the same. My office was the same, my lab was the same. And for me, there were personal considerations why I wanted to stay close to home. So that's what I did. So I continued the same lines of research. And as I said, this is a no-go normally if you want to do an academic career. It's not recommended to do that. I also tell my own students that finish now, if they want to stay in my group, 9 out of 10, I tell them to forget about it and to go somewhere else to learn something new. The 1 out of 10 that I allow to stay in my group, I allow to stay if they can really change the research topic and learn something completely new. And that was the case for me as well. So I got a big opportunity to stay in the same research group, to become a project leader and to supervise the subgroup on polymer chemistry of the Schubert group. And that was a subgroup of 10 researchers, and I had involvement with all of that project on a day-to-day basis. So I was immediately actually having my own small research group, even though it was headed by the professor. And then at the end, I started to realize that maybe I had to differentiate a little bit. So that's when I decreased my appointment at the DPI to 0.7 FTE, and I took up a part-time position at this SME, so small and medium enterprise, called Dolphus Medical. And there I was involved with developing drug delivery devices based on near-infrared triggering of implants. And that was really to broaden my knowledge and expertise. And as you see, this is a very unusual move to stay in the same group. But as long as you can explain why you do that, so the way I explained that is that, well, it's unusual, but I got a massive opportunity to have my own subgroup of 10 researchers who would not accept that and stay a little bit longer. So if you have 10 researchers, you stay 3 years, they all publish, let's say, 4 or 5 papers in those 3 years. I'm involved with all of the projects. You can do the maths and you can really boost your CV in that way. So it all depends on opportunities and where you want to go later on. Okay, so then towards the end here, I started to work at this SME because I kind of decided I wanted to go for an academic career, but I wasn't really sure how to do that because people told me, well, you don't have your own profile. You're just working the same things as Professor Schubert does. So yeah, what do you want to do if you want to be independent? And at that point, I actually continued building my network. So I wasn't really sure what to do. So I reached out first to Bert Meijer in Eindhoven, and I made an appointment. I said, well, what can we do? What can I do? What's the best way for me to move on? And he gave me a really good advice. And he said, well, just if you want to have an academic position in the Netherlands, then people should know you in the Netherlands. So why don't you just contact some professors in the Netherlands and just ask them if they are willing to talk to you? So that's what I did. I contacted 3 famous Dutch professors, and I just sent them an email. I said, well, this is my background. I would like to stay in academia. Do you have time to have a chat? And then they all replied that they were willing to do that. So one day I drove to Delft, one day to Nijmegen, and the third one is probably to Groningen, just to talk to some people and just let them know I'm out there. I'm looking for a position maybe in some years from now. And what they told me in those chats, and that's, I think, important to share here, is that I should do a postdoc, to go abroad and make sure that I do a postdoc with somebody famous. And they told me the status and accessibility of your supervisor is most important. Well, accessibility, not even. One of them even told me, well, if you go and clean the labs with an extremely famous professor and you don't publish anything, this will already help your CV. So just being associated, being accepted by a high-level researcher helps your own CV to move on. Then it's preferably to have own funding, because if you go to a famous professor, you have your own money, then you have much more freedom and you can just be working on your own projects and gain own visibility. And then possibility for supervision, well, that's also kind of numbering up. So the more students you supervise, the more research you can do and the more output you can create. So I took this all into advice. So I put one slide here on how to get a personal grant, because it's the best way to go for a postdoc is if you have your own money, your own personal fellowship. And to do that, you should write an innovative and challenging, but at the same time feasible research project proposal. And that's probably the most difficult part, to decide what's innovative and challenging, but still feasible. And at the same time, you need to differentiate from previous supervisors. So the first time I submitted my proposal to the Humboldt Foundation, it got badly rejected because some of the reviewers said, well, this is just doing the same as what Schubert did. So I learned from that. So the second time I completely changed. I made more clear what was my own input, my own ideas. And then later on, I was successful in getting that. So you also need to demonstrate your independence. And there's different ways to do that. It's not always easy to control this, but main authorships of publications. As a PhD student, this is mostly first authorships. If you're becoming already postdoc, at a certain point, if you bring in some own money, you should talk to your supervisor and ask if you cannot start sharing corresponding authorships for some publications, because that further helps to show your independence. Invite and presentations help. So during my project leadership, after 2 years postdoc, I had a good network. I had a couple of good friends that were organizing conferences, and I just was brave, and I just reached out to them and said, well, I know you're organizing this conference. Would you be willing to give me an invited talk? And of course, it's not really invited if you ask it in that way, but on your CV, it's an invited talk. So the worst thing that can happen if you ask that is that they say no, and then it's fine. Then one person knows that he said no, and for the rest, nothing happened. So I think you should always try to be opportunistic. And if you know people organizing conferences, why not see if they want to help you or not? Well, the rest, I think, is clear. So international collaborations, again, building network. If you have an idea to collaborate with someone, just reach out to colleagues, talk to your supervisor, of course, ask if it's okay that you start a collaboration with another group, and then we'll try to get the publications. So based on that, I managed to get the second time I tried this Humboldt Fellowship in Germany. I went all the way abroad to the RWTH Aachen. This professor here, Martin Muller, it's 10 kilometers across the border, and I still lived in the Netherlands. So I was actually commuting from the Netherlands to Germany, but on my CV, this is an abroad postdoc, and it is as valuable on your CV as going a full year to Berlin and really living there. Well, despite just being 10 kilometers across the border, Germany, especially 10 years ago, it was a very different world. So when I went into the lab, we had our group meetings and group seminars. I raised my hand to ask a question, and then it was Herr Dr. Hoogenboom, and then I could ask my questions. A very formal way of addressing each other. They don't clap by clapping their hands, but they knock on the table to acknowledge somebody after the lecture. So it's quite funny to see the different type of the way they address each other and work together, even though it's just across the border. Unfortunately, in that year, I didn't spoke so much to this professor, just 2-3 times. He was quite busy, but those 2-3 times he was very helpful and really challenging my ideas and asking me, yeah, but why are you doing this? And somebody did this 10 years ago, so shouldn't you be having more bigger dreams? So really pushing me to be creative and very critical to the research ideas. So don't do too much Me Too research, also in your own careers, but really try to do new things and try to break new grounds. Nonetheless, he is an important reference for me. He's an important contact also on my CV, and it really helped me to go further. In this time, I also supervised 2 PhD students. They helped me to get even more output. And because I had my own grant, I also spent some time to write a review. I did this as a single author, so he was fine with me doing that. That was actually on polyoxazolines. So I just wanted to make clear to the outside world that the polyoxazolines, I did a little bit in my PhD, but it was really my topic and not just from my former boss. And then the second postdoc was in Nijmegen. So that was a VENI grant from NWO, from so for the people in Flanders, this is the Dutch analog of FWO. This is Professor Roland Nolte, a very famous, again, scientist. So I really tried to go to this famous scientist. At the time, he was editor for Science, very accessible, very helpful, and still today. So I was lucky enough to get 2 weeks ago an award from the American Chemical Society, and then in the award symposium, Roland gave a very nice lecture. Also, Bert Meijer, they gave very nice lectures. So still, until today, I have very good contact with those mentors. At that time, in Nijmegen, there was Professor Nolte, but there were also Jan van Hest, there was Floris Rutjes, and they all had one team together. And I had the freedom to go to all the group meetings of all these professors, and I just went there just to learn new ideas, just to get inspiration, and just to make the most out of it. And I started a large number of independent collaborations at that time, because I had my own funding, I had my own freedom to do what I wanted to do. So there I was, in my idea, I was on track to become an assistant professor in Nijmegen in some years. So this was in 2009, roughly. And in the Netherlands, once you're in as a senior postdoc and you really show that you can do good science, then normally this automatically then goes towards becoming an assistant professor. So that was my plan to do that. But then life happened and things are not always easy to plan. And what happened is that I got a phone call from this guy, you saw the picture before, Professor Philippe Dupré. It turned out that he was quite impressed with my PhD defense, and he had been following my research over the years. And in roughly 2009, I think, he called me that there was a BOF-SAP call in Ghent and BOF-SAP. That's BOF is the Special Research Fund of the university. ZAP, that's the name they give in Belgium to the professors, zelfstandig academisch personeel. And this BOF-SAP call, that was a call to give 6 young researchers the opportunity to become independent professors at Ghent University. So 6 positions for the whole university, so 2 for the betas, for the Faculty of Science. And he gave me a call and he informed me about this and he said, well, I think you make a chance if you apply for that now. So that's what I did. I wrote a research program, what I wanted to do in Ghent. I'm sure that Philippe Dupré behind the scenes also did some lobby work for me. So he helped me a little bit to talk to people from the panel. And then, you know, what happened? I'm here now as a professor from Ghent University. So I indeed got the position. And in 2010, I started my position in Ghent. So here you see that actually the circle is round. I've been telling you, very important to work on your network. And this is how it happened for me. I, at that time, never considered going to Belgium or to Flanders to become a professor. But then just because of the network, I was tipped that there was this opportunity to go to Belgium. And then I did. So I have one slide. So I did not do a lot of comparison between the Belgium and the Netherlands because for me, I think both countries are very good to start an academic career. It's not exactly the same, but there's no good and no bad. There's just different nuanceations that I have experienced over the years. So the first different nuanceation is, I think, the formality. So if you work in the Netherlands, it's extremely informal. So as a master student, I could go with my NMR spectrum, knock on the door of Bert Meijer, and just say, just address him as Bert. So I didn't say Professor or Professor Meijer. Just hello, Bert. I have this NMR spectrum. I have a problem. I can't really integrate or assign my peaks. And then he would just take time, a couple of minutes, to help me to assign the peaks. Well, also the same with the secretaries. They would just be very informal with the professors, and everybody is the same in the Netherlands. In Belgium, this is a little bit more formal. We have a bit more hierarchy in the system. So up to today, after 10 years, the people from administration and the reception, they still call me professor. I've told them many times in the beginning, well, you can call me Richard, there's no need to call me professor. It's part of their system. They keep on calling me professor, and it's just the way they work. It's a little bit more formal in addressing each other. So there's no good, no bad, it's just different. A little bit tricky is sometimes the hierarchy in Belgium, because the different ranks of people, they do not always like to talk to their higher ranks. So it may happen that certain groups of PhD students, they don't feel confident to talk to the boss. So I am aware of this. So I tell all my PhD students, well, please treat me as one of your equals. Just if there's something wrong, immediately tell me what's going on. I would like to know everything that goes in the lab. I will not get angry at you because you tell me something, but please just keep me in the loop. And in this way, also the students, I tell them, well, don't call me professor, call me Richard, especially PhD students. We have to work 4 years together. So then I don't want to have this barrier of you calling me professor. Now, another important difference is the way of organization. I know this is not completely black and white, so there's some differences in the Netherlands and there's some difference in Belgium. But the groups I worked in the Netherlands, they were usually very large research groups. So they had a full professor like Bert Meijer, and then in the same group, today there's even 1 or 2 additional full professors in the group. Then there's a bunch of associate professors and assistant professors all in the same group. And especially the assistant professors, they don't have the same rights as the full professors. So they cannot promote their students. So they can get a grant for a PhD student, but then in the end, the full professor is the promoter and not the person that got the money in. Whereas in Belgium, especially our department also, we work more like the US system, meaning that if you're assistant professor, associate professor, or full professor, that doesn't really make a difference. You all are fully independent. You have all responsibilities, and all benefits from having your own research group. Well, because of this, there are some differences. So in the Netherlands, because of that organization, you generally have a very strong support if you start, because even if you don't get grants as an assistant professor, you will still be involved in supervision of the people working on the grants of your colleagues. So there's always budget available to at least be involved in research. In Belgium, the way I was starting my group, I was completely on my own. So if I would not have been able to get research projects granted, I would not have gotten PhD students. So then I would just be there on my own doing my teaching, maybe going into the lab myself, but that would have been it. So you're kind of thrown in the deep and you have to swim to get your money. Well, if you are okay with that, it's also a very good system. It's just a little bit more pressure to get that going. Well, then because of that, there's also a large difference in visibility. So if you're just starting as assistant professor, the visibility in the Netherlands is lower than the visibility in Belgium. So what I mean with that is that if you do something really great scientifically in the Netherlands, but you're assistant professor in the group with Bert Meijer, and you have this great JAX paper where Bert Meijer is a co-author, people will only see Bert Meijer and they will not see your name. Only maybe by the 5th or the 10th paper, they will start recognizing, oh wait, this guy is also always there. And then you get some visibility. If you do the same great science in Belgium, in your own group, with your own funding, with your own high risk to jump into the deep water, you will publish it on your own. You will not have a another famous professor on the paper, it's just you, and people will immediately recognize your name. So for me, this is the main difference that I experienced. So you're responsible for everything, but you also get the benefits for everything you do. And then, well, the last point, I think connections and network, I've been stressing this. This is going to be equally important in the Netherlands and Belgium. But for me, at the times, as I said, I didn't realize I could go across boundaries and across borders, that I could go to Belgium. But I think nowadays it's definitely for you guys an option to keep this in mind, realize that you can equally work in Flanders or in the Netherlands. Teaching is the same language. If you're Dutch and you teach in Ghent, sometimes the students think you have a funny accent, but that's it. They do understand what you say. And then just to wrap up here, just some concluding remarks. So if you're a Master of Science student or a PhD student, and you're aiming to go for an academic career, then, well, today already start working and considering your independence. Start working on your international network. Take opportunities that come along, so you can have a very beautiful career planning. But then if another opportunity comes along, just take it and go for it and be opportunistic. Try to get your own funding if you go for postdoc. Make sure to supervise some students. And last but not least, don't forget that there's also something besides the work. It's not always easy to get this balance right. But yeah, make sure that you also keep that in mind, that there's a good balance between work and private life. And with that, I'm at the end. So this is a brief overview of my career path, what I've learned over the years, and I hope it can be of any help for you, the younger next generation, to pursue an academic career. And the questions will be later, I think.
Yeah, thank you very much, Richard, for your inspiring words and interesting career path so far. So indeed, the questions, you can still put them in the Q&A section on the Zoom platform. And afterwards, we will now immediately continue with the lecture of Timothy Noel. And afterwards, we'll have a common discussion, a Q&A discussion with Richard as well as with Timothy. So I will first introduce you to Timothy Noel. Timothy obtained a master's degree in industrial chemical engineering in 2004 at the KU Sint-Lieven in Ghent. He then started a PhD at Ghent University at the Laboratory for Organic and Bioorganic Synthesis. Afterwards, he joined the group of Professor Stefan Buchwald at MIT as a Fulbright postdoctoral researcher. And in 2012, he started as an assistant professor at the Eindhoven University of Technology. And in 2017, he became an associate professor. Since 2020, Timothy was promoted to full professor at the University of Amsterdam, where he is chair of flow chemistry. His main expertise is in the field of flow chemistry, homogeneous catalysis, and organic synthesis. So then I will give now the word to Timothy.
Thanks, Nathan. And it's a great pleasure to talk about what we have been doing in the past couple of years. And as Richard already said, it's not a standard presentation. It's a little bit different. And so actually, a lot of what Richard already said, I can echo that. And then you will see some repetition of that. I think everything that he has said, I fully agree with. It's really important to work on your network. I mean, it's one of the most crucial things, because these are the people that are going to, well, help you at the right stages of your career, and they can maybe push the door open for you. And then, of course, it's up to you to really keep the door open. But getting those doors opened are not always easy. And I will give you a brief overview of what we have been doing, or what I have been doing. And I will not talk about my research. So I think that's a little bit outside the scope of this presentation. I just will show you a little bit about it. So I started in high school. So really at the beginning, I did Latin Sciences in Aalst in Belgium. And I graduated in 2000. And so what I learned there is really to get to know myself. So you know what you like. I really liked sciences. It was something that I apparently was good in. And so I really got good grades as well. And so in that regard, I always like to push myself a little bit to the limits. I like the competitive aspect sometimes of academia and of studying. And so this was really important. And then to select the next stage was a little bit similar to what Richard said. I like mathematics, I like physics, I like chemistry. And then in chemical engineering, you find a little bit of everything. So I went to industrial ingenieur, which is for the Belgian students, you know, it's an academic education, but it's not the same as burgerlijk ingenieur. And by choosing this track, it's very clear that I was at that point not thinking about a long-term academic career, but it was really a track that I'm very happy that I did it, because I really loved it. But maybe later on, especially during my PhD and my postdoc, it didn't always help me. Because of especially in Belgium, it's a bit lower ranked, they say, although I completely disagree with it. And I think my career has shown that there actually is not so much difference in that. If you have talent for science, you can make it from any track you want. And it's also what Richard already said, you don't have to have a traditional career path. But you can get from every angle into academics. That's also what I can say. But during that track, I also got familiar with organic chemistry, and it was something that I really loved. I mean, the classes that I did was always the ones that I selected, and it's also the reason why I then selected in my second year chemistry and not physics or mechanics, because I also love those things. But yeah, you have to choose anything. And then apparently organic chemistry was my big thing. And then in the last year, I had to select a master thesis, and I had the opportunity to go to Ghent University, same department as where Richard is now working. I think his labs are on the first floor. Mine were at that point on the ground floor with Johan van der Rijken, but he also had labs on the second floor. So that's where I did my master thesis. And again, I had the feeling I really like research. I really like pursuing this. And so that's why I wanted to do a PhD. But at that point, you still had to do a pre-doctoral training because you're switching fields. And although personally, I think it's a great thing to switch fields, Richard also mentioned that already a couple of times. At that point, there was still a so-called pre-doctoral training in chemistry. And as I say there, it's really one of the most useless tracks ever. It's 30 credits. Most of the stuff that I've done there was exactly what I've already studied during my industrial engineer, but it showed that those people that wanted to do it, they really wanted to go for a PhD. degree, and we were with 3 that year, and from the 3, 2 really finished till the end. One of those 3, she went to industry in the end. She said, okay, maybe PhD, I don't want to put in the efforts, but 2 out of 3 definitely went into a PhD track. But during that year, I also got to know a little bit, do some research in the lab of Johan, and that really kept me going. Because as I said, this was a track, and I think they also canceled in the meanwhile, which was actually a last year. So then I started my PhD in 2005. I got some BOF funding. I graduated in 2009, and the topic was synthesis of chiral ligands, so a little bit different from what my master track was. But you really learn quite a lot of different things, and actually I would have done anything. It didn't matter. I just wanted to do research, except maybe for analytical chemistry. That was really something that I didn't like, and I still don't like it a lot. I like it to use it, but I don't want to do a PhD in it. So that was the only thing that I didn't want to do. But besides that, I just love research. So if it was going to be in chemical engineering or organic chemistry or inorganic chemistry, it would have been all fine for me. And so during that PhD, you rapidly feel if you like working in a lab or not. And it's something like I essentially every day, I really enjoyed working there. And maybe there are days that are a little bit off, but I think it's definitely important that you have passion in what you're doing. And so in year 3, I started to decide, and I started to analyze a little bit the CVs of other people who actually started in academia. And then I really started to think about doing a postdoc, because that is the way and the track that you have to go there. And as Richard also said, it's not wise to do your postdoc in the same group, because if you do that, you're just doing every time the same. So you need to challenge yourself. And so I was lucky. I got in 2010 a Fulbright Hays Award, and I could go to MIT to work with Steve Buchwald. And to my surprise, I was asked for doing flow chemistry. And then at that point, I was like, hey, wow, what is this about? I didn't even know what it was. I've done some engineering. I've done some organic chemistry. Flow chemistry was a terminology at that point that I wasn't familiar with. And so, but okay, you're like super excited. You're happy that you can start there. And so that was my first reaction. I mean, this was a big deal. And regardless if I was going to continue in academia, that was a plan, to be honest. I really wanted to become a professor. But yeah, you don't never know. But by going outside of your comfort zone and going abroad, it doesn't matter if you're going in the end then for academia or for industry. It's actually good for both tracks. And so once I got in there, I knew, I mean, this is going to be a big deal also for my industrial track, if that was going to be the plan anyway. But anyway, I gave it all for going into academia. And the second reaction was, as I said, like, oh my God, I'm going to MIT. This will be like the Champions League for academics. And is this not going to be very challenging? And is this not going to be too much? I mean, you never know. You're still doubting yourself. You're young. It's very normal that you do that. But once I started there, the first 2 weeks doing flow chemistry, it was really a perfect match, actually, with my backgrounds as chemical engineer and as organic chemist, working with pumps, trying to do some chemistry in very like small capillaries with few hundred micrometers in their diameter, and making the connection between chemical engineering and organic chemistry allowed me to rapidly move forward and really make some breakthroughs in this field during my postdoc. And so I also had the feeling that I sometimes knew more than the students that were already there, just because I could combine those two fields very elegantly. And so after 1 month, I realized, hey, this is going to be my topic for the future academic career. If I want to do an academic career, this is going to be the one that I can do. And so this is also a picture of my fume hood when I was still working there. Yesterday, I was looking for some nice pictures, and this one was that popped up, and actually it brings out some memories, which I think very fondly of. So then I came back and I started applying for jobs, and as a Belgian from Aalst, and at that point living in Ghent, close to Ghent University, I was, that's also when I think I met Richard for the first time. There was one of the things that Richard maybe didn't mention is that it's not so easy to get a position in Belgium. I mean, if you don't participate at BOF ZAP, and there is no opening, it's going to be very difficult to create a position. While in the Netherlands, as he correctly pointed out, if you're there a postdoc, you can sometimes flow into the academic path like that way. But in Belgium, it's impossible. So I started applying then in the Netherlands. I applied in Utrecht and I applied in Eindhoven. They both had open positions. And twice I got the position. And so I then selected Eindhoven because they had quite a strong team, like with Jaap Schouten and also with Volker Hessel, two people that were really known characters within the field that I was working, microreactor technology. And so the kickoff topic that I really wanted to move forward was flow chemistry with a focus on photocatalysis. First of all, because photocatalysis was an upcoming new field, which just started like really booming in 2008. And I had the feeling that it would boom by the use of flow chemistry. And so I really tried to be independent from day one, because as Richard said, sometimes you're dropped into a large group in the Netherlands and they treat you sometimes more like a senior postdoc, you know, like you don't have independency. And I said from day one, I'm going to get my own grants and I want to be independent. And that was one of the best things that I've said, because there was some resistance by the full professor in the beginning. And I said, it's take it or leave it. Either we do it like that or I'm going. And so he said, okay, you can try. And so I really got my own independent grants. It really worked out well. And so what I want to say also as a tip is that you have to be very open and vocal about what your ambitions is. What is your goal? What do you want to achieve? And I said that from day one, and it really helped. And if you don't open your mouth, you're maybe like blocked, and then it can take ages before you become full professor, if it already happens. Because there are sometimes people also that well, retire as an assistant or even an associate. So, so it's very important. And I already said in the first month, I remember at that point, the dean was Jaap Schouten. I said to him like, hey, how can I become full professor? And he said like, oh, don't rush, guy. You still have plenty of time. But I think he already felt at that point that I was really ambitious. And I think if people know your ambition, they can call you at any moment. And that's what happened in Richard's career. That's what happened in my career. It's also important to be a great colleague, but you also have to be firm in what you really want to achieve. As I said, I really could collaborate very well with the full professor, but I also said these are the limits that I want to establish myself on. And so you have to be very firm about that, because if I didn't do that, yeah, probably sooner or later, they would walk over you and maybe even take your ideas and have that for themselves. And then, okay, you're screwed. You have to start it all over again and find a new topic. So I always said some things we can negotiate on, others not. And then I'm very firm on the non-negotiable. I say, okay, this is a no-go, but all the other ones, no problem. I want to be collaborative. And in that way, you have a friendly relationship. They know that you're very ambitious. They know what your limits are, and they will not cross them, because they just, if they appreciate you, they will really, help you in that thing. So I also say, pick your fights, but don't not fight for everything, because you don't want to have for each breadcrumb to fight. I mean, sometimes you just say, okay, it's not worth it. You can have whatever it is. But if you really think it's important for your career, then you definitely need to ask it and be bold about it. Really say, hey, this is going to be important, and then explain it in a friendly way. And mostly you get your way. It's not going to be always a yes, but if you don't ask, you don't have anything in that regard. And so last year, I had the opportunity to become full professor at the University of Amsterdam, and I think it's definitely something that I wanted to grab with my both hands. And our mission has actually hasn't changed since that day that I started in Eindhoven. It's really, we try to develop technology which is going to be expanding the available chemical space for synthetic organic chemists. And so in that regard, we really try to achieve everything and try to solve all the issues that might be an issue for synthetic chemists. Like think about gases. I mean, some of you might have worked with it. You know, it's a pain in the ass. It's difficult because the gas needs to diffuse into the liquid. Well, that's a problem that we like to solve. And that's some things that we have done. And we really try to position ourselves by merging organic chemistry and chemical engineering in one single research line. And in that way, we are quite unique in the entire world. And that's very important in the long run. You want to have a research line that is, if people say, okay, it's flow chemistry, they need to come up with your name. You don't want to be the gray mouse, and that's like in some fields are so full and saturated that it's almost impossible to establish yourself. And so this is also important to make the move from assistant to associate to full professor, because if you don't have an own research line, it's nearly impossible, definitely in the Netherlands. I think the first step to get to assistant professor, it's quite straightforward, but every single step further than that is very challenging in the Netherlands. I would even argue that it's more challenging than in other countries, because there is really in that way a hierarchy that the full professor is like, it's really important to be that in the Netherlands, because otherwise it's like they only associate the research group with the full professor. So with that, I would like to also say a few things that I think are important. And one of the first thing is that you really need to believe in yourself. I mean, there are going to be bad days, and you have to remember the good days at that point. So you also have to be very careful of the ones that try to pull you down. For me, especially during my PhD, I was an engineer, and yeah, sometimes behind your back they say, oh, he's an engineer, he doesn't know what he's doing on organic chemistry. But well, that of course pissed me off big time. But that just gave me more courage to work harder and show them, hey, I can do it. But you cannot allow those people to get you, because you will find them everywhere. There are always, it's easy to criticize somebody, but it's much more difficult to then really do something about that. And what you have to do is do not always believe it. Try to take criticism not too bad. Try to learn from it, but don't let it pull you down. Don't let it demotivate you. Because also when I said, for example, I want to become a full, like a professor during my PhD, they just laughed because it's extremely hard. I mean, it's not easy, and a lot of people try it. But I always said, yeah, okay, I will try my best, and if I don't succeed, okay, I at least tried it. So what my motivation is actually this one that I found once on Twitter, actually, from Philosophie magazine, is when you have bad luck, it happens all the time. Grants that are rejected, papers that are rejected. It's really the time to show you have character and do not give up at that point. And it's actually, I printed this one, and it's hanging in my office, and so that I can regularly look at it, because it's going to be part of your career, whether you're going into academia, whether you're going into industry, and even in normal life, it's part of what we are doing. And so it's okay to be down and to feel sad about a rejected paper, about something that happens in your private life. But after a few days, try to get up again and keep fighting, because you don't want to, falling down is fine, but getting up is much more difficult. And it's that will show you that in the end, you will get there. And what you will see also is that a lot of people that are in academia, they all had bad luck, even the stars. And they just had to fight, every one fight at a time. And so it's like climbing stairs, you do it step by step. And sometimes you need to go 2 steps back, and then you keep going again. And in that way, you reach the top in the end. So the second lesson is, do not give up. Finding money for a PhD is challenging. I remembered I was really stressed out. I mean, FWO, BOF, IWT at that point. There are so many options to find a PhD in Belgium. It's a bit different from the Netherlands, where it's typically associated with the professor that has money or not, and then you just apply. But in Belgium, it's typically that you have to find your own money to get started there. And it was the same thing with the postdoc. I remember at a certain moment in 2008, when I was starting looking for a postdoc, I was going to go to Aachen, and the professor, I will not name the name, he promised me a position, and then 1 year later, he didn't deliver on that promise. And so I had to all of a sudden reconsider my options. And so, well, actually, you would say, okay, fuck, this is really annoying, right? I mean, you put all your, you didn't look for anything else. You really counted on that position. But okay, I had to, either I could stop, and at that point you think maybe it's not going to work out. But then a couple of weeks later, you're sending out all these applications, and then you get a letter back from, or like an email back from MIT, and they said you can go, and as soon as your visa is accepted, you come. And I mean, that was one of the greatest days of my career so far, because it really made the breakthrough for my career. So finding an academic position was the same thing. I was applying at that point for an FWO postdoc, and to my surprise, although I had already 2 papers during my postdoc, I didn't get it. And then people said, yeah, you should try again. But I was really down at that point, and I, yeah, okay, I allowed that for 1 or 2 days. And in the meanwhile, Stephen Buchwald from MIT, he had heard about it. He came to me and he said, don't worry, I'm so happy about how you're doing here. You can stay as long as you need, and you will find a position anyway. And by the way, he said, why are you applying for another postdoc? I think your CV is already fine enough. You should immediately apply for academic positions as an assistant professor and stuff. And so I said, you're sure? And he said, of course I'm sure. And so that's actually the push that gave me to immediately start applying for academic positions. And yeah, half a year later, I started in Eindhoven. So actually, it's not so bad if something gets rejected. Maybe next time you do get it. And so this is also a poster maybe some of you recognize. This is Briek Schotte during the Tour of Flanders in the 50s. And he didn't win that race. And I also say to my students, it doesn't matter that we win every battle, but as long as we try our best to get that paper accepted, and if it's good research, it doesn't matter if it gets into science or into JAX or Angewandte, or if it's good science, it will be recognized. And so Briek Schotte, on that specific day, he only got second in the Tour of Flanders. But those of you that like cycling, and especially in Belgium, a lot of people do, they know that this guy had a fantastic career. He became world champion twice, I think. He still won the Tour of Flanders. So that day, he was only second, but the next day he wins. And so I also say to my students, this is the type of attitude that we should have in our group. So the second or the third lesson is really about international experience. And that's also what Richard said. It's you experience a lot of new things. For me, it was going to the USA. I never went further than Ghent. I mean, from Aalst to Ghent, it's like half an hour drive, and that was the furthest I went. And you really need to experience things, because it's not only great for your academic career, if that is what you're pursuing. It's actually also good if you're ambitioning a track in industry, because with something like that on your CV, people know, hey, this is somebody that is motivated to go to do something for their career. And so these are the people that you prefer to hire in the long run. So you get immediately a great network of contacts. And just to show you, this is a picture from 2010 at a party. As you can see, we were drinking quite a lot of beers. This is a Duvel that was actually mine, because I am Belgian, so I love Belgian beers. But here, for example, this is Deb Mighty. He's now professor in India. Here you have, he's in Nanjing, Xiao Wang. Brett Force is at Cornell. Tom Amoni is at Berkeley. I mean, I can at least name a couple more. I think half of the group is now in academia, either as assistant, associate, or full professor. And then the other half are actually in top pharma positions. I mean, most of the research that we are doing is on pharmaceutical type of work. And so the other ones are at the top pharma level. So like Merck, BMS, like AbbVie. And what is interesting of such a network is that, as Richard also said, these people are the ones that are going to be your peers in a couple of years. So you try to give each other a lecture at a certain symposium, or like just before Christmas, he's working at 3M. He invited me to give a lecture at 3M. At this point, it's of course all virtual, but it still helps you a lot to broaden your network immediately and really have that ambitious, ideas that you're having there. So surround yourself really with motivated people and keep each other motivated. Because sometimes when a grant is rejected, we seek each other's approval. So sometimes one of my friends, Chao Wang, he said, "Oh, my papers was rejected. Can you have a look?" And so I give him some feedback on his paper, and I said, "Oh, maybe this is not good," and we appreciate it because we know we are in different stages of our career, or we are working on different disciplines. We still know each other quite well enough, and in that regard, we give honest feedback to each other, while a complete stranger doesn't always dare to say that to you. So that is why networking is important, and so you immediately have a very broad network in that regard. So the fourth lesson is actually, it's not easy. You have to really work hard. So you need a good CV. Richard said that as well. Without papers, it's going to be challenging. You can be extremely talented, but if you don't have papers, you need to show something, right, on your CV. And if you don't have the papers, it's going to be tremendously challenging to be competitive to other people in there. And so you need also that CV, especially when you're just finishing your postdoc, to get those first grants. And with that first grants, you can have new PhD students, you can start doing your own research. And with that new research, you can ask new grants, and so on and so on. So it's a kind of a rat race where you need to constantly show that you are the right person. That means you have to work your ass off every single day. You have to grab your chances. Every chance that passes by, you have to grab it. Of course, be selective. At a certain moment, you don't do everything anymore. You don't do the things that don't push your career anymore forward. Or sometimes you just do it because you think, okay, I think this is important for that or that reason, or for yourself. But in principle, you can start being more selective. So you have to also be able to say no to some things, because otherwise you're overflowing with work. And really collaborate also with your network. The more people like you and the more friendly you are to your colleagues, the more they are willing to support your later stages of your career. That's going to be very, very challenging. But you need to keep a balance. I have seen people working extremely hard to get tenure, especially in the US. It's an exceptional hard race there. And then once they have tenure, they're so burned out that basically you don't hear anything from them anymore, because they are just, I mean, I'm happy I have my job now, and I've done so much in the past couple of years that I cannot sustain this anymore. So it's important to work hard, but also to put in some moments where you are together with your family, or that you do things with friends, and that you need that to keep sane, and to put also stuff in perspective. If a grant is rejected, if a paper is rejected, it's not the end of the world, because if you don't do that, everything is going to be disappointing, right? And so you need to keep sane, you need to keep healthy also, to be and perform the best way you can. It's also important to challenge yourself, switch topics in your careers. It shows that you dare to take a risk. You're going to be much more interesting to future employers, both in academia and industry. And so if you're successful really in different fields, people will also believe that you can do anything. Whatever they throw at you, you will find a solution. And I think great scientists really can do that. And then like what I've tried to do is then you bridge fields. I've done my chemical engineering, I've then done organic synthesis, and then I started flow chemistry. And so I could bridge things in a very different way than other people were doing that, in which was already present. So one of the important things is also, do not copy your advisors. Don't be a copycat. It's not fun. Mostly your advisors will not appreciate it, that you're trying to, essentially you're competing with them. And it's going to be hard anyway, because you're starting off, they have an established group. And so how are you going to compete with somebody that has 10 times more manpower than you have? So it's going to be nearly impossible to do that. So don't do it. Try to be original and try to find a discipline where in a couple of years they say, hey, if you put these keywords in Google, that your name shows up as maybe one of the top 5 people that are listed there. So try to be different, try to be original, and really dream big. Do not be incremental. Try to reach for the moon or shoot for the stars and then eventually reach the moon. It's still a great achievement. So you really need to try to tackle the big challenges. That's something that I learned, especially in the USA when I was doing a postdoc there. So for postdocs, when you then want to roll into the academic career, you have to try and write proposals. Typically, you have to do 3 proposals. One with a very challenging idea, which is maybe not even possible, but just shows how creative you can be. The second one is like average difficulty, and then one with low difficulty, which is certainly going to get you good papers. And so those 3 proposals, I also did the same thing, although it was not really necessary to get a job in Europe, but it definitely streamlined my thoughts. And then and then you have like an idea, okay, this is where I want to go in the next couple of years. And then another important lesson is that you really need to have a goal. Where do you want to be in 5 years and where in 10 years? This is if I have new faculty trying to apply for a job, this is the first question I ask those people. And if you don't have a good answer on it, I'm not going to be that positive about that candidate, because if you do not have a vision and do not have a goal, how do you know where you're going to? So it's like climbing different mountains, and if you just climb every mountain like 2 or 4 steps, and then you go to another mountain 4 or 5 steps, and then another one, well, netto, you're staying on the same level, so you're not moving any forward. So you have to have a very clear mission and vision statement, and as early as possible, so that you know where you're going and keep on that track. And every day you try to learn new things. You like, for example, when I realized during my PhD that the bottleneck of getting my papers fastly into literature was really the quality of my writing. So if I gave a good paper, and I say that to my students, if you write a good first draft of your paper, it can be submitted within a week. But if I get a shitty one, I need to completely rewrite it. And then it depends on, the amount of time you have during your weekly schedule. And I can tell you that can take a little bit longer time. So what I did then at that point during my PhD is I said, okay, I will only read books in English. So I started with simple books. I started reading the Harry Potter series only in English. I started following courses on writing. I tried to analyze papers which were very well written, and that I thought, hey, I like this paper. Why do I like it? And how do they make that message clear? And so you invest in that way in your career. And so now I'm reading a lot of books on management and trying to keep track on that and learn on that. So this is all important. So you know, okay, this is the goal I want to get there. What do I all need? And then you work one by one on all these topics to get to that goal that you have set for yourself. So you use that goal also to keep you motivated. So then it's also not so important if, like, on one day a grant doesn't get approved. Okay, doesn't matter. We will do the research anyway. So I will do it. I will try another grant and another grant, and eventually you get a few approved. That's very normal. So you need to have that goal to keep you motivated to get up every day, because you know there is still a lot of work to be done, and then to do whatever it takes to get to that finish line. So it's extremely, extremely important. And then the last lesson is I think an important one. I don't see my job as a job. It's not work for me. It's more like a hobby. This is a statistic that I found somewhere. Like, apparently 75% of the people do not actually like their work. They really do it to get money, and they see it as a chore. And how can you stay motivated day after day? You lose your motivation. So if you're in it in academia to think you have a nice life and forget about it, it's a lot of work. And if you don't like it with your entire heart, it's actually going to be very, very difficult to keep going. So you have to find a job, whether it's in academia or in industry, that you're really passionate about. And then Steve Jobs formulated as "stay hungry, stay foolish." He said at a certain moment, what's the best career advice you can give me? Somebody asked him, and he said, well, maybe first, if you haven't found the best job you have, then maybe quit, go washing dishes or do whatever, and then use the time that is free for you to think about what you're going to be, what you can be passionate about, and really do that, and then go all in. And in that way, you can succeed in any career that you want to do, whatever it is. And it doesn't matter what you do, as long as you like what you're doing. So do not forget also, this is my last slide, that being a professor is actually not about being smart. It's much more. You have to have excellent management skills, because I think the people that are most successful, they all have really great management skills. They know how to motivate the team. They know how to coach them and get the maximum out of a team. I always compare it also to a soccer team, where you have sometimes really good coaches that have maybe not the best team, but they know how to make every player what ticks with them, which position they play best at. And so they restructure their entire game to work with the team they have. In that way, they can play champion. I mean, sometimes you see that with like small teams that become champion, and that's like, how is that important? They only have so much money. And it's really about a great coach. It's I think definitely underestimated within academia. I also want to say that academia, while it's a lot of work, it's also a lot of fun. You meet so many people, and yeah, okay, during the pandemic, it's a little bit more challenging to have all these networking. But if you like networking, academia is definitely where you meet a lot of people. And so maybe the last thing that I really want to say is like, really go for it. And when you have the dream, just do not let anybody stop you. Keep going for it. It's going to be very, very important to not give up. And if you push hard enough, you will open the doors that you want to open. And I really believe in that. With that, thank you for your attention. And if you have any questions for me or Richard, feel free to ask them.
Okay, thank you very much, Timothy, for your wise lessons and advice. So indeed, if there are any questions, just ask them in the Q&A section. There already were a few I saw. The first one, you mentioned, and especially, actually both of you mentioned, that going abroad is very important for a future career in academia, even if it's just across the border. So is going abroad remotely the same, or is the association the most important?
Richard, you can start.
Yes, can I start? Yeah, so I can start. So, in my opinion, it's the combination of the two. So, if I would have stayed in the Netherlands and just worked with the famous guys like Bert Meijer, Roland Nolte in supramolecular chemistry, this would not have brought me where I am. So I needed to go to another famous guy abroad. And in my case, this was just abroad. But on your CV, it's going to Germany, going abroad. So that's really important, because as Timothy also said, it's a proof that you're willing to take some risks, that you're willing to invest in your own career, and that you're really going for it.
And for yourself, the experience as well, I guess. So.
Yeah, I fully agree with what Richard says. Well, I went to the States. And in the beginning, I was also, I mean, I never crossed an ocean in my life. And it was a bit, well, terrifying. I must admit. I went there all alone, and yeah, you don't know what is going to happen. But in the end, as we both agree upon, is it shows that you have something that you're willing to go for. And people back home, they will say, hey, wow, this guy is going to do whatever it takes to get that goal. And even if you don't get it, I mean, even in the industry, I applied when I came back to McKinsey, and they said to me actually that having done a postdoc abroad is for them really a show of having character and not staying around what we call in Belgium rond de kerktoren. So stay close home and be scared and just want to go home to mommy every day. I mean, to be honest, the first 5 months, I lost a lot of weight in the States because I didn't know how to care about myself, to be honest. I just worked too much. But on the other hand, you learn so much about yourself also in that regard. You learn new cultures because, as Richard also pointed out, between Belgium and the Netherlands, it's quite a big difference. And you see that even if it's only like 10K across the border in Germany, it's like a whole different world, different way of doing things. And that's the same in the US. I think most importantly, you have to work for big stars, and that's also, they help you.
Okay, thank you. So the next one is more for Richard, because Richard was at a certain point a bit doubting if he was really going for an academic career. So what went in your mind during that time? And if you didn't go for an academic career, what career would you have chosen and why?
Yeah, so that's indeed. So I mentioned that at the time I was a project leader for Dutch Polymer Institute. I had some doubts if I wanted to go to industry or stay in academia. That was actually one of the reasons also I took up the part-time job at the spin-off company from the University in Eindhoven to actually experience how it is to be in industry. And I liked that job. I really liked to work towards a drug delivery device that was supposed to be working in the clinic. But then I was responsible also for the scientific strategy of that spin-off company. And we had some beautiful science going on, which didn't fit the goals of the company. So I made the decision, well, it's beautiful, but we're not going to look at it. We're just going to leave it behind. And that's what made me realize that my love was more with the science and understanding and not in making the product. So that's the moment that I said, okay, then I should really focus on my academic career, build my network, get advice from people that have done this before. And that was for me the most important. So if I would have stayed in industry, then it would have been in trying to get into basic R&D, which only few companies do nowadays. So it's all applied. So basic R&D, then you think about DSM in Geleen, you think about Philips Research, they do a lot of chemical science, BASF and Ludwigshafen. But it would have been really doing exploratory research because that's the thing what I love. And there I also agree with Timothy, being a professor doing science, it's more like a hobby, which is a risk because you really need to stop with your hobby to spend time with friends and family also. And if it's a hobby, then of course you spend always too much time on it.
Okay, that's a clear answer. I don't know if Timothy still have to add something on this or...
No, yeah, actually, I completely agree.
What's your opinion on leaving academia and coming back after a break? For example, after some time working in industry, have you ever seen that happen?
More in the Netherlands, I would say, right, Richard?
Yeah, that was indeed the same I was going to answer. So I have hardly seen this happening in Flanders, whereas it's quite common in the Netherlands. So some of the most famous guys, Bert Meijer, I told you about, he worked at DSM. Veringa, he worked in industry, and they came back after seeing the challenges of industry. Then they tried to address, and that's how they also decided to have more application and more relevance, not application, but really relevance of the research and science they are doing. So if you want to go that approach, then better apply in the Netherlands than in Flanders.
They really like it actually. In some, like for example, in the technical universities, TU Eindhoven, TU Delft, TU Twente, they really like that entrepreneurial type of people also within the faculty.
Yeah, so the spin-off company I worked with, that was with a professor, Jos Keurentjes, who worked at Axo Nobel. And then he came to the university in Eindhoven to become a professor. And the day he started, he told the dean, I will be 10 years professor, and then I go back to industry. And that's what he did. So he made some really great science, some science papers, spin-off company. And then after 10 years, he went back to industry to continue working there. So in the Netherlands, they're really open to these kind of hybrid models.
The next question, it's a bit in the same trend and maybe they're more straightforward in the Netherlands. So let's say you're not interested in a full career in academia. How do you keep contact with the academic world while working in industry? So because he thinks that the bond between both is very useful and important, and how, as a professor, do you like to keep contact with the industry?
Yeah, sometimes you also have people in the Netherlands that are like part-time professor, like 10%, 20%. And typically these are people that are from the industry,
Okay.
where they want to have that technological impetus within the tracks. But also, I mean, you have Marie Curie ITN programs, and there you, in most of these, well, grants nowadays, you have to have industry participation. So that's also a way via grants. And actually, we as academics, we are constantly looking for those type of people to have them in our proposals. So it's kind of doable. Yeah.
Yeah, maybe I can add also if it's just really about staying in touch and keeping up to date what's happening, then of course the first thing to do is go to international conferences where the scientists are presenting. Make sure you go to an ACS meeting. Just pick a session that seems a bit interesting and then stick the entire session, so you get surprised by lectures that you would normally not choose to go to. And yeah, I think that's the first one to think about. You can of course always collaborate with the people in academia, but then you either need a proposal, and like Timothy said, ITN, or you need budget to have a bilateral project to work together. But you can also, well, there's also consultancy options, and also in Flanders we do have guest professors from industry that take some of the courses and show examples of industrial relevance of certain subjects. So it's about reaching out to people. If you're interested to do a bit of teaching while you work in industry, well, you can just ask a professor if it would fit somewhere in their study program or not.
Okay, thanks. What's the best way to stand out of the crowd when applying for a PhD? Do you have any tips, and how do you let know people when you are the right person for the job?
That's of course a difficult question, because that's very early in the career. So you depend much on the circumstances. So of course you have to show what you're worth in your master thesis. If you can do an Erasmus Day semester abroad, this can make you stand out already. Involvement, we have some people here at KVCV-KNCV, so they are showing their commitment to the chemical sciences. So all these kind of extra things that can make you stand out when you apply for a position together with 20 others.
Yeah, and also having good grades. I mean, it's not holy. I've had once a student that did a master thesis with me, and well, I once told him if I would have only judged you on your grades, you would never have come in. But he did such a great job during his master thesis that I said, wow, I need to have this guy. He was amazing in the lab, and he proved to be so also. He did a fantastic PhD. But also, I mean, if you're already interested in somebody, it's again networking, starting early to contact that professor, just have a chat. Most of them are allowing that, and show them your interest in it. That helps as well.
Well, that also leads us to the next question about creating a network, especially for PhD students who are in the early days now. Creating a network under the current circumstances with COVID, how is that possible, or how do you have tips for those people?
An email here and there, I would say. I would not overdo it either. I mean, we get a lot of emails, so you want to, ask for a chat, like Richard also did, some things like that. But it's definitely not so easy. It's much more easy on a physical. Because now also you're asking the questions. Normally they would raise their hands. You have eye contact. When the meeting is done, you have a beer together. It's all much more fun than how we can do it now.
Oh, the one tip that comes too late now, but many of the questions are asked by the anonymous attendee. And there's a couple that actually have the name associated. So, well, the ones where we see the name, there's a chance that maybe in the future, if they contact us, then we say, oh, I've seen that name before. And then in that way already you get some visibility. I agree, it's extremely difficult now. So what I said, well, in a conference, go informal to the speaker, ask a question. It doesn't happen with the online conferences because you have a chat box and there's too many people there and you don't have one-to-one speech. So if there's a professor in your field that has done very nice research, you see a new paper, you can always drop them an email and say, well, congratulations, I saw this paper. It's very much related to what I'm doing, then briefly explain what you do and maybe ask a very clever question so they know that you have actually some ideas about what they're doing.
Yeah, when you write a letter or like a cover letter when you're going to apply, what I really like in cover letters is that they know the research that we are doing, that they really know, like, hey, I like that. Just select one or two papers. These are two papers that I really love. That's why I want to work for you. Make it personal. Show them that actually that one page cover letter is that you worked on it. And that's not like, oh, it's very clear that this person sent it out to 20 other because it's so anonymous.
Yeah.
That also helps. Make it very personal.
I had also a question because Richard mentioned, for example, that he had a review as a single author. So that gives you indeed more visibility. But is it also a good idea to have a lot of authors that are renowned in the field? Which is the best, do you think?
Well, it depends a little bit on the goals you have, I would say. So if you want to build your network, and in that case, it could be a very good idea to initiate to write a review article and invite the most known people in your area and invite them to be a co-author. You do most of the work. You just send them the paper for some revision and some fine-tuning and final input. And then you have built your network. They all like you because you give them a review article for almost no work. So that really helps for your network. If you're that one author that does most of the work, but there's 10 famous guys of your area, they will not associate that field with you as the unknown author. So when I wrote my single authored review, this was really to gain visibility in that field for myself. And therefore, I actually decided to even not include my former supervisors, even though I worked on related topic with the former supervisor. I actually dedicated it to that supervisor to kind of not get any trouble with him. So it was for his very early, actually, I think it was his 40th birthday. So I dedicated the paper for his 40th birthday, a review in Angewandte. And in that way, I managed to do, but you of course have to very carefully communicate to the people you're working for. If somebody is paying your salary, you cannot just do that. If you have your own money, then you can tell your supervisor, well, I want to spend some of my money, my time on my review. So that's important. And then, well, maybe a related question in the chat, because somebody asked how important these review articles are in your CV. I think they're very important, but it should be with moderation. So if you have a publication list with five articles about science and 5 reviews, this is going to be seen as a bit ridiculous, because that means you have spent most of your time learning about all kinds of different fields rather than doing science. But if you have a publication list with, well, 5-6 papers and there's one good review, then this is very valuable for your CV, especially if it's in one of the good review journals. Think about review in Angewandte, review in Chemical Society Reviews. ChemRef I wouldn't recommend because you spent half a year writing that. They are so long. But then it shows that you comprehend the entire field. you can bring things together. You can make a very high level review, and that shows that you're mastered the area. So definitely go for it. Generally in my group, the introduction is of a PhD thesis is used to also publish as a review.
And a review, you also get into depth in a topic, and you see also the gaps. So it can also serve, for me, it's always a lesson in where can I still go into? Because then you have really a thorough overview of what has been done. And then you see also the gaps where maybe it's useful to work on. For that reason, a review is important. But I agree with Richard, you don't want to be a writer, you want to be a scientist.
Okay, yeah, thank you very much. I think we're almost, with the most important questions. I think they can still contact you if they have additional questions. And then I think we can hereby close our first evening of the KVCV and KNCV Chemistry Career Night. I want to thank our three speakers, Leana Travaglini, Timothy Noel, and Richard Hoogenboom again, for their very interesting talk. Thank you for sharing your knowledge and experience you have within the academia, and I'm convinced all this information was very useful for everyone who wants to pursue an academic career. I also want to thank the audience for their active participation, and I hope to welcome many of you at one of our next events. As a reminder, I can also recommend you our second career night, which will take place on the 28th of April, so next week, and this will focus more on the chemical industry. But this one will be in Dutch, so it will only be for the Dutch-speaking people. And then I can only wish you a good night and see you next time. Bye.
Bye-bye.